Hi students, welcome to the class. Today's session we are going to discuss about in our second PUC unit 2 solutions. Okay. First, any chapter we are going to know about some basic introductions and the definitions and basic terms. In this chapter of solutions, the solution, already you know the meaning of the solution, because of this is not might not be a new word. This is early section in first PUC or in your high school sections. You did know the meaning of solutions. Okay. So today one more time we recall about all the important terms briefly. The first is the basic terms like the solution having solute, right? Then solvent, then solubility. Okay. So, and having a classification. How they have classified on the basis of physical states. Okay. In the physical states of solute and solvents, they classified or types of solutions and examples. Okay. Second point. And under the involving of having a solution, some of the losses like Henry laws and Raoult's law. Okay. This is very, very important in this unit. Henry and Raoult's laws. Okay. And this the properties. What are the solution having the characteristics and properties belong in the solution we discussed in this unit. Apart from all these things, we are going to discuss the problems regarding of these losses and properties to get in this unit. Okay, this is about the solution chapter. It's containing 9-hour unit. The marks of weightage is 7 marks of weightage. In the 7 marks in the final examination appear in your question papers. 1 marks, 2 questions carries 2 marks. Okay. And this is part A. And part B, it's containing 5 marks, 1 question, 5 marks. Total 7 marks. Okay. This 5 marks is not exactly asking in a single question. They may ask 3 marks, 1 question, and 2 marks, 1 question. Total 5 marks. Okay. This is regarding of your scheme of blueprint about solution chapter. Okay. So 9-hour chapter containing 7 marks of weightage. Okay, students. So let me go for the introduction and the definition about the solutions. So first thing, you take 10 gram of glucose in 100 gram of water. Okay. So here, this is the beaker taken. This is what? Water. And you just insert the glucose to the beaker. Okay, students, here observe. This is a pure substance. Is pure substance solid. Okay, glucose is a sugar, this is a solid content, and this is water. It having it's also pure substance. It's a liquid. Okay, both were to get a mixture. It's forming to get the glucose is inserted in the water containing anything that was to forming of mixture. The glucose na water alli enagutte glucose water mixture agi formation agutte. Okay, what's the meaning of mixtures? They are classified in your first PUC. Some of the concepts of chemistry, the first unit, already know that the definition of mixtures and types of mixture is. What are the types of mixture? It's having two types. This is what? Homogeneous mixture and heterogeneous mixture. Okay? So what's the meaning of mixture? Mixture is any pure substances, two or more, mixed together to forming of mixture. In that, two types, homogeneous and heterogeneous. To take sand plus water. We observe sand and water. They have to be mixed together. What is the giving? That layers will be formed. Sand is lower part and water they can forming of two layers. Will be appeared in the two layer formation. That make what? This is heterogeneous. Okay? Heterogeneous means the layer formation are there. The concentration not be throughout. Uniform concentration irodilla. Clear? So come to the homogeneous. Homogeneous, okay, is one of the example of homogeneous. Glucose added to the water to get what? Glucose solution will be formed. Okay? Glucose solution will form. So, in this glucose solution, you take a homogeneous. What's the definition of homogeneous? It is any substances. Homogeneous means what? Two or more compositions or concentrations or properties are mixed together throughout the and uniform throughout the solution. Okay, this is called what? Homogeneous. ಅಂದ್ರೆ ಏನಾಗ್ತಿದೆ, ಪದಾರು ನೀವು ಎರಡಕ್ಕೂ ಮೂರು ಕಾಂಪೋನೆಂಟ್ಸ್ ಗಳನ್ನ ತಗೊಂಡು ಮಿಕ್ಸ್ ಮಾಡುವಾಗ ಅಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಥ್ರೂಔಟ್ ದಿ ಸೊಲ್ಯೂಷನ್ಸ್ ಇರುತ್ತೆ. ವಾಟ್ಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಟ್? You take for example, here is 10 gram of glucose, 100 gram of water. So they make what? 10 into percent with 100, 10 gram and 100 grams. You get what? 10% of glucose is present in these solutions. You taken this portion to get calculated. This is giving a 10% of glucose solutions. You take here also 10%, you take here, anywhere. Means what? The concentration throughout the solution is uniform. Either taken 1 spoon of glucose solution, you taken to taste it. It's giving a sweetness. Okay? That same thing, you taken this portion. This is also giving the same taste. What's the meaning? The uniform concentration throughout giving similar and identical properties. Okay, this is called homogeneous mixture. Okay, now going to the definition of solution. Solution. This is one of the glucose solution, right? The solution means Solutions are homogeneous mixtures of two or more than two components present. Okay, this is called what? Definition of solution. Solutions are homogeneous mixture of two or more than two or more components or presents. Components are present. It is called what? Solutions. Okay. What's the meaning of component? Yes, the component means what? Component. It is any substance which made up of the solution. Prepare ಮಾಡೋಕೆ ಬೇಕಾಗ್ತಕ್ಕಂತ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳು ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಕಾಂಪೋನೆಂಟ್ಸ್ ಅಂತ ಕರೀತೀವಿ. Okay, so in this solution, do you observe it? 10 gram of glucose in 100 gram of water. Okay, so what are the components are present? 10 gram. In this 10 gram, this is a smaller portion. This is a smaller component, right? It is what? Smaller component. Okay. What about 100 gram of water? It's having higher upper large component. Okay, so smaller components are called what? Solute. Larger components are called what? Solvent. Okay. What's the definition of solute? Solute. The components, right? The component present in a smaller quantity in a solution. Clear, students? This is about the definition of solute. Solute is the component present in a smaller quantity in a solution. Okay, what about the solvents? Solvents means, yes, the solvent, the components present larger quantity in a solutions. Okay, students, this is about the solute and solvent definitions. Okay, so in a solution containing what? Solute and solvent. So one of the solute and one of the solvent is present. It is called what? Binary solutions. What we call? Binary solution. Binary solution, solution containing one solute and one solvent. It is called what? Binary. Two. Okay, one solute, one solvent. So in your second PUC, unit second of solutions, we discuss only the binary solutions. Okay, so if by chance you get and some of the time 3 or 4. Okay, so we take a ternary Ternary means what? Three components are present. Okay, 1, 2, 3. Three components are present. Assume that in that third one having a larger number of compositions, it is taken as a solvent. Remaining two were solute. Clear? This is a three component presence. This is called what? Ternary. Either you taken 4, this is quaternary. Okay, this is as quaternary. One of the components is presents larger number, that is called what? Solvent. Either remaining one, solute. Okay, students, this is about the definition of solutions and components and solute solvents. Okay, so now going to the important thing is, in a solubility, we check in our PUC of laboratory. In the laboratory, you will conduct the test of the solubility. For example, compounds like urea, with these dissolved in water, right? The water is a larger portion and the solid substances in a smaller portion to check the solubility. Okay, so now is important, what's the compositions or component to be determine the physical state. Let me know it. Physical state ಅನ್ನೋದು ಯಾವ ಕಾಂಪೋನೆಂಟ್ ಬಳಸಬೇಕು ನಾವು ಕಂಡುಹಿಡಿತೀವಿ. Okay, so first thing I given one of the example to you, right? Say glucose and sugar. Okay, 5 gram glucose is there, either glucose or urea, plus 100 gram water. So here, this is what? Solids, right? This is liquid, and this is containing smaller portion. Smaller portion we call it as what? Solute. This is a larger, the value is 100 gram. This is a larger quantity. So it is called what? Solvent. The solvent, how is our physical state? How we calculate the physical state? It's based on solvent. Which is the solvent is? Liquid, right? It's the liquid. So this is called what? Liquid solvent. Either liquid solution. Okay, this is called what? Liquid solution. Solid solutions, liquid solutions, and gaseous solution. Okay, what's the definition of liquid solution? Liquid solutions. Okay. In this liquid solutions, very simple. What is the acts? Solvent is acts as a larger portion. So a solution in which, what's that solvent? Is a liquid. Liquid acts as a solvent is called what? Liquid solutions. Clear? So one more example I have taken. So copper in gold. Okay, copper in gold. So already know that gold having a how much carats? 22 carats, 24 carats. So like the gold having a 22 carats, like 22 parts of gold, 2 parts of copper. Okay, the copper is a solid, gold also solid. So just see here, 2 parts of copper. 2 part means this is smaller quantity, is a solute, but it is both were solids. 22 parts of gold. 22 means larger, this is solvent. Okay. So in this case, what's the solutions? This is what? Solvent as a solid. This is called what? Solid solutions. Clear? Same as like gaseous solutions. Okay. So next one is solid solution and gaseous solutions. So solid solution in which solid acts as a solvent. In this case, gas acts as a solvent. Clear? This is about the solid solutions, liquid solution and gaseous solution to be determined the physical state. Okay, this is physical state to get calculated by using solvents. Clear? So now going to the classification. How they are classified in the solutions are classified belong with the basis on physical states of solute and solvent. Let me know it. It is clear. Okay. Okay, students. So next we going to the classification or types of solutions. See here, classification of solutions under the basis of physical state of solute and solvents. Okay. So first, let me know one by one types of solution. Okay. Types of solution. What are the types? The first one, solutions having a types before we know it. Solid solutions, liquid solution and gaseous solution. First we take a solid solution. Okay. So in that solid solution, solvent we prefer for always solid. Okay. The solute also taken in the first case solid. Okay. What are the examples in taking a solvent also solid and solute also solid? The example were copper in gold. Okay, copper in gold. Either we take alloys. Alloys means metal alloys. Okay, the alloys means was mixing together two or more metals to forming us alloys. This is a solid and gold also solid. They make what giving a one of the best example to giving solid preferable solid solutions. Next was solid is a solvent and also third one is a solid. Because of solid we prefer to that solid, liquid and gaseous, 3 forms of matters. So let me know it. Second one was liquid and gases. In the second one is liquid as a solid and solvent as solid. So this is having an example to giving amalgam of mercury in the presence of the sodium. Either mercury and silver. Clear students? This is an amalgam. Solid of sodium, liquid as mercury. Both were mixed together, homogeneous mixture forming as amalgam. Mercury and sodium or mercury and silver. This is an example we taken in the case of liquid and solid. And third one is, this is preferred in a medical field of dental recovery. Okay. So then third one is solid gas. The gas is taken a solid. The example of third one, gas and solid. The gas is hydrogen molecules in Pg. This means what? Palladium. So one of the palladium element is a solid in the hydrogen gas molecule. This is mixed together. This is one of the best example to giving an example of gas solid solutions. Clear? This is the first one. Okay. So second one, say liquid solutions. Liquid solution means solvent. Solvent acts as a liquid. Okay. So in this case also say the solvent may be taken what? Solvent is might be taken always liquid, and also liquid. Okay. So solid. First we consider solid is a first of a solid. What are the examples? Example for the solid and liquid. Yes, I taken the first example. Solid as a glucose, urea or sugar. Yes, glucose or urea or sugar in water. Okay, so water is a liquid, solid is a glucose. Mixed together, homogeneous formation. This is a binder. Two. One is a solvent, another one is a solid. Okay. So next is liquid as a solvent and solute is liquid. Liquid solutions. In this liquid, we consider the examples of liquid. Liquid has what? Ethyl alcohol or what? Ethanol in water. Okay? Ethanol in water. This is a liquid. This is a liquid. Both were mixed together. So one of the best example we consider in liquid solutions. And next was gas and liquid. So gas is liquid is a has taken water in oxygen in water. Oxygen is a gas. Either any carbohydrated drinks like carbon dioxide in water or oxygen in water. This is in the example of gas liquid. Clear? Okay. So next is third one. Third one is gaseous solutions. Okay. In this gaseous solution, we consider the solvent as absolutely gases. Okay. Gas, and gas. Okay. First we consider solid, liquid, and gas. Clear? Okay. What are the examples we consider in a gaseous solution of solvent is gas and the solute is solid? The first one is the solid is camphor. Camphor is a solid. In gases, which of the gas we consider? Nitrogen gas. Or N2. Nitrogen gas is mixing with camphor. Okay, camphor is a solid. Nitrogen is a gas. Did you observe? This is an example we consider solid to convert gases. This is called what? Sublimation. Did you understand? Sublimate. What's the meaning of that? The solid directly convert to the gaseous form. Solid is liquid, then convert to gaseous. But the solvent is directly converted to the sublimate method. This is for example is camphor is directly going to the gaseous form. Okay, clear? Okay, so next one, liquid and gases. Liquid and chloroform, CHCl3 or chloroform in nitrogen gas or N2. Nitrogen gas is one of the form of solvent taken a gas, and chloroform. They make what? Chloroform liquid. So gas is nitrogen. And the last one, gas and gas. These are air molecules in the atmosphere. Oxygen and nitrogen. Oxygen gas and nitrogen gas are called as air. Okay. This is the classifications, 9 types. Okay. These are the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th type classification we observe in the under the physical state of solute and solvent. Clear, students? This is about the examples of each one of the solutions. Clear? And note down of this chart. Okay? Thank you.